Hi, I'm Christina. Welcome to Intersection STEM for Girls lesson. And here we're going to have a new series of computer science. For me, I am a CPR, which is competitive programming learner. And here I want to introduce some trick to use when I'm doing a US SEO contest, and also some trick or problem that I found interesting about competitive programming, and also some strategy that you can use in competitive programming contest. And today we're going to see a very interesting silver division problem in USICO. It is called convoluted interval. It is in silver division, but it's pretty interesting, and I guess you can learn a lot from the trick that I provide in the video. So let's see. And the problem I choose is USICO 2021 December contest silver division, and the problem is convoluted interval. And let's see. The problem says the cows are hardworking and try to invent a game. And one of them, the current endeavors involves a set of n intervals. So we can see there's an important letter comes out that it is n, and n means the number of interval. And we can see how to define interval. This is very important, right? So the interval starts AI and BI for the nth interval. So how to define interval? It is AI to BI for the nth. And then we also discover another important letter, which is M. We can say both AI and BI are integers in the range of 0 to M. So this is a range of integer. And M is relatively small, we can see in this place. And let's see how they play the game. This is probably one of the most important things in this problem. Okay, B will choose some interval. Let's see the I's interval here, and LC will choose some interval. J's interval here. Okay, probably the same. This is something that we must notice. For a given value K, they win if AI plus AJ is smaller than K smaller than BI plus BJ. So for a given K, AI plus AJ smaller than K smaller than BI plus BJ. Okay, so this is how they are going to win. Here, I guess I'm a bit confused what we're going to do with this problem. This is only a property that if we satisfy it, it will win. But what we're going to count, and let's see next. For every value of K in range 0 to 2M, there's a 2M plus 1K. And please count the number of ordered pair IJ in which B and E can win a game. This is the most important sentence in this problem, I guess. So we're going to count each K in the range 0 to 2M. We're going to count the number of ordered pair IJ, and this ordered pair can win, so that we can win. So this is a strategy counting problem. Like for each K, we're going to count how many ordered pair IJ that we can choose the interval to satisfy this property. Before that, we're going to go through the input and output format, which actually we can guess. Let's see. We're going to be given like N and M, and then N interval, right? AI and BI as interval. And for the output format, we'll print a 2M plus 1 line, and each line is for each value of K. We need to count how many number of ordered pair IJ. So this is something we can guess. And also, we need to look at the range of the important capital letter. For example, like we're going to go capital letter N. It is at max to multiply 10 to the power of 5, which is a relatively large number. And let's see, M is relatively small. It is 5,000. So seeing the range of those N and M, we come up with a really easy idea of not to use N. If we can use M to replace N, we'd better do that, because N is too big, and no way we can use time complexity of N squared to get a full score in this problem. So we'd better use M more than N. So let's see how we're going to do the problem. And also let's think it straight. For each K, we're going to count pair IJ, right? But it is relatively hard in this point. Like for example, N equals to 10, and there's a lot of interval we're given. How can we find this pair of IJ? Personally, I think it's pretty hard, because if you can find something satisfy this property of AI plus AJ smaller than K, but at this time you cannot satisfy this property, and it is really difficult to balance these two, and it is pretty difficult for you to do it with array or something. So I think at this point we need to introduce a trick, which is swap the thing you're going to count. Swap the thing you're going to count. You are going to count. So here you're going to count what? You're going to count for K how many pair IJ you can have. But we can swap it up for each IJ as a pair. For each IJ, how many K it can satisfy. And if we have an array answer K, which is the number of pair IJ that they can win. So for each IJ, we're just going to add answer K for the K that satisfied this IJ pair. So that we can swap the thing we're going to get, and things becomes easier, because if you got an ij, it's really easy for you to find like what k it can satisfy the property that it can win. It is just in this range. So there's a very easy solution at this point. We first go through 1 to n and then another 1 to n and find a pair of ij, and then use this ij, and then use like ai plus aj to bi plus bj, and in this there's a range of k. We can each add answer k in this range. And then we can try to analyze the time complexity of this solution. There's n squared because there's 2n, because we're going to enumerate I and j, and also there's a k because we need to add answer. So k's range is actually m, because m's range of integers. So this is n multiply m. This is the time complexity of this problem. So it is too big to get a full score, but we can get some partial score by using this trick. Let's go back to the problem. Let's see how many score we can get. I guess we can get this one, right? Or this one. But this is really a partial score. And how we can solve, we can make a little adjustment is by using the second trick called perfect sum. Because we observe that we need to, in this problem here, in the third enumeration, we need to add from ai plus aj to bi plus bj, and it is consecutive index of an array. So we just need to add 1 and minus 1 in the perfect sum array to maintain the function of adding a consecutive index of array. So we only need to do 2 adjustments in a by using a perfect sum idea. So you can reduce 1 dimension. Okay, and so that here the time complexity became n multiply n is n squared. So it is you can satisfy the first 5 test cases. And finally, we got an idea, because I also mentioned that sometimes we have to use some small number to replace the large number, right? Because n is too large and m is too small. Why not use m instead of n? So that we can use small range to replace large range. So here, we need to create array to count n into m. Count m by using n. So that array is kind of like, for example, the A array, it is like am what, and how many n can satisfy can be m. So in the next step, we're going to enumerate m instead of enumerate n. So it is kind of like tricky things to change what we're going to enumerate by counting the number and change it to the other thing you're going to enumerate. For example, there's a lot of number. They have different value, but their range are pretty small. So you just need to count each value, like how many numbers is that value, and you're going to enumerate the value instead of enumerate the index of the number in an array. So that's probably the trick in this place. And then let's go into the code. We can see m is the range I already remembered. Okay, and also here you see in the other input. We're going to see AI and BI, right? Before using it, we need to mention xn, because we got n. xn. And after do that, I said we need to transfer index to value, so we need another thing to transfer value. This is max m because the value is at most max m. So we enumerate the 2 values that consist of a k. And here, we need to do this, because for each start, you add 1. And here use prefix sum. For each start, you add fai multiply faj, so that for each start, it can satisfy like it is larger than I plus j. So at the start of I plus j, you need to add the start of the array that can satisfy your property. But at the end, like what thing here should be minus? It is fbi multiply fbj. Because here, these 2 things cannot satisfy. It is beyond the range, so you have to minus this 2. This 2 line, they're not telling about the same thing actually, but you have to do that, because if you doesn't minus it, if for adding it doesn't minus it in the future, it will count as 1 and do perfect sum. But if a thing you add in one place and you minus in the same place, it won't count, because it doesn't belong to the place. And if a thing you add here and minus here, it will be a perfect sum. And this is pretty much the core of this problem. And also here, at last, we're also going to do a perfect sum because this is what we do this problem. Something weird. Something. Oh, we also need to use long because the values and the weight of combining so much. It's kind of like n squared or something, but we need to use long at this point. What happened? I had no idea. Okay, but doesn't matter. Oops, it's here. Let's fix it. To long lot because the way here, because you add something after multiplication and you will square things up, and you'd better use long in this point. And that's probably all of my solution. I guess this will get you a full score or something like that. And hope you enjoy this video or something. And sorry if the background is kind of noisy because my family are enjoying it after leisure time. Yeah, I'm sorry about that. And thank you for your patience. Yeah, thank you.